Hello, everyone. Good morning, good afternoon, or good evening, depending on what time you're watching this video. It's me again, Teacher Kent, and today we're going to continue more about fossils. The truth is, I wanted to introduce you to fossils last week, but because of the holiday, we could not have our class. But it's fine. Let's continue learning all about fossils. So I'm going to share a screen about the fossils, the fossil PowerPoints. Now, paleontology, the study of past life. Okay, paleontology, that's where people studied the animals or the remains of animals that are not found anymore or are considered extinct. That is the branch of science that studies them, because science is not just one thing. It's actually a whole lot of different branches that you can, if you want to learn more about a specific branch of science, there is a specific subject for that. The science that we know right now is what we call general science. It's what everybody should know. If you want to learn more, when you go to the university, you need to pick which science subject you would like to learn more about. So, paleontology, the history of the earth would be incomplete without knowledge of the organisms that had inhabited our planet and the conditions under which they lived. Do you ever wonder why or how scientists guess, like, for 1,000,000 years ago, there used to be a big dinosaur that eats other dinosaurs called T-Rex? How do they know that? They know that because they studied the remains or the fossils of past animals, especially T-Rex. The science involved with the study of past life is called paleontology. Okay? It's a study of past life. It's how you studied life before. Paleontologists study fossils, which are the remains of organisms preserved by geologic process. Okay, paleontologists, those are the scientists that study paleontology or the study of past life. How do they know? How do they know what to study about? They study about fossils. Preserved remains of a past organism. Those are called fossils. See that? There's a fish. There's a snail-like animal. There's even a big millipede type of animal. There's like a big dog or a horse. And there's also is that a dragonfly? I think that's a remains of a dragonfly. All these things are fossils. And these are not man-made. Man found this out when they dig through the earth. They found the bones of other living animals or former living animals. They're not really alive anymore. So how are fossils formed? Fossilize, the process of becoming a fossil. Fossils are evidence of past life preserved in rock. Most fossils form when living things die and are buried by sediments. The sediments slowly harden into rock and preserve the shapes of the organisms. Okay. Remember last week I said that fossils are usually found under sedimentary rocks because fossils are usually found under a rock. Because if it's not protected by a rock, the fossils will probably not be clean or will not be formed normally. And the best type of rock for a fossil to be preserved is the sedimentary rocks, because when sedimentary rocks are formed, they are just covered by other sediments. So imagine a small dinosaur dying on like a riverbed or a place where there's a lot of water, and suddenly it rained. When it rained, the body of the animal stayed in the riverbed. The water from the rain takes the sand and the soil or the land from the nearby areas, and it will cover the body of the small dinosaur. After thousands of years, when people start to dig around, we will find the skeleton of the animal. We cannot find like the body itself. We cannot find the meat because, as you know, the meats are often eaten or decomposed by earthworms. The earthworms do not eat the skeletons though. So usually when we see fossils, they are most probably in their skeleton form. If they have some sort of bodies left, it's not really that clear. It's not really fossilized too. Let's continue. The fossil record and life. The fossil record is the complete body of fossils that show how species and ecosystems change over time. So what do fossils tell us? Fossils provide evidence of how life has changed over time. Fossils help scientists infer how Earth's surface has changed. Fossils are clues to what past environments were like. Basically, a fossil is like a storybook, okay? If you know how to read, you know what the book is trying to say or trying to tell you. So how do we read fossils? We study paleontology. Paleontologists, they know how to read fossils. And because they know how to read fossils, they themselves can tell us how a fossil is formed or how the fossil used to live. How did we know that there were dinosaurs before us? Because we found their big bones underground near lakes and rivers. So we know that for a time before, for many millions of years before, there were these big, gigantic animals known as dinosaurs. Fossils help scientists infer how Earth's surface has changed. Now, I said before that fossils are usually found under sedimentary rocks. But teacher, isn't it true that some fossils you will not find near rivers and lakes? Yes, it's true. And how is it true? It's because a place that was a lake before may no longer become a lake now. Do you understand what I'm trying to say? Let's say there is a big lake here in Suphanburi. There's a very big lake. But you know, Suphanburi is very hot. It rains, but not as much. Even during rainy season, it's still hot. So the rain, water will slowly be evaporated. If it doesn't rain for many years, the lake will dry up. So what will happen? That lake before will not become a lake anymore. And the other animals will just bring soil, even the wind will bring soil, dust, and cover the lake before. So for what we are, let's say for example, in Suphanburi, this may be a school right now, but we don't know. Maybe before it was a lake. And how do we know this? If we find a fossil under the earth, that means that for a time before, this place was under water. Fossils are clues to what past environments were like. That's it. If you find a fossil and you notice that the fossil is like, it shows, let's say for example, you find a fossil. And the fossil is a big fish, but you find the fossil on a desert. So what does that tell us? It tells us that before the place was a desert, it was once probably a lake or something that has water, because there is a fossil of a fish, and fish live in water. That's it. So let's watch a 2.5-minute video about conditions that led to fossil preservation of an early human. So I'm going to show you that video right now. Let's listen and watch. Oh, it's a big, like...
It takes a rare set of circumstances to turn a living creature into fossilized bone.
That's true. It's really hard to make a fossil. That's why fossils are very, very valuable.
In the case of Lucy, the famous hominid fossil, discovered in Ethiopia's Great Rift Valley in 1974.
Okay, Lucy is actually a fossil, and not just any fossil. Lucy is like a fossil of the earliest humans.
There is no evidence that she met a violent death.
Lucy just fell into the water pond. And maybe she died or he died, because it's Lucy, so it's probably a girl. She died on the water, and her body sunk to the bottom of the water. Just like that. I hope you can see what I see, please.
No predator or scavenger found her body before it began rotting in the lake's soft sediments.
Okay, so this is what's important. Because if, like, let's say a lion or a T-Rex found her body would have been eaten. But because she died on the bottom of the ocean, of a lake, no other animals except the earthworms and the other small animals that eat bodies at the bottom of the ocean were able to eat her body. So she was preserved. That's it. Her hand slowly becomes a skeleton. Her body decomposed.
Her bones, which settled in the mud, may have been cracked or shattered by animals roaming around the shore.
Oh, I see. So her bones might have been cracked or shattered because some animals go to the lake to drink water. But because it's a bone, it doesn't have any meat, they don't eat it. They might have cracked it while stepping on the bones, but that's it.
Heavy rains gradually washed in enough sand and gravel to bury her bones.
Oh, a lot of strong rains came in, and it washed like sand and gravel onto her bones.
These deposits built up over thousands of years, burying her remains hundreds of feet deep. The calcium in her bones, molecule by molecule, was replaced by minerals from these deposits, ultimately turning the bones to stone.
Oh, her bones turned into stone. That's amazing, because it shows us that when we die, our physical body might die, but our bones, they can last for a very long time.
She remained buried over millions of years, while the Earth's crust moved constantly, forcing the remains of her body closer to the surface.
We know that the Earth's crust continuously moves, so that must be how her body, which was buried before, was slowly pushed up to the Earth's surface.
Heavy storms beating down on the Earth eroded the sediment, and most likely brought her once again to the Earth's surface.
Oh, I see.
Her exposure made it possible for anthropologists to later discover her remains some 3 million years after her death.
Imagine that. She died 3 million years before after, but her bones were still there. She became a fossil. And because of that, we were able to learn more about human history on what our ancestors might have looked like. But that's it for today. We'll just continue this discussion next time. Bye.